You guys, we're going to talk about the circumference and area of circles today. Really, it's just plugging things into the formula. So the circumference of the circle is the formula 2 pi r. Pi is that, we're just going to use that pi symbol on our calculator. But if you wanted the decimal point approximation of that, it would be 3.14. But really, let's just use the pi on our calculator. And then the area formula is pi r squared. So that's the formula for the area of a circle. So I think you've done this probably lots of times over the years, but let's look at this first example right here. It says to find the area and the circumference of the circle. So while we're looking at this, if we're going to do the area first, we're going to do pi times the radius squared. So pi times, anybody know what the radius is of the circle? If the diameter is 10, yeah, the radius is going to be 5. Nice. So I'm going to do 5 squared. This becomes a calculator problem right there. We're really just going to punch that in the calculator and get the solution out for that. So do pi times 5 squared. And when you first do that on your calculator, it's going to leave it in terms of pi. It's going to give you like 25 pi, just like this. That's what my calculator gives me. But if I hit those arrows again, it will give me that decimal point approximation. So 78.54 would be my area. Because this is in centimeters, I would be centimeters squared, because area are square units. Okay. I do the same thing when I'm looking for the circumference. I just use that formula. The formula for circumference is 2 times pi times the radius. What did we say the radius was? We said it was 5. So 2 times pi times 5. Punch it in your calculator. That's going to give you the circumference, the length around the outside of the circle. So 2 times pi times 5. Yep, 31.41. And if we rounded that 1 up, it would be a 2 because of the 5 behind it, right? So I'm going to go 31.42. And then this is just centimeters because it's the length around the circle, okay? So area is figuring how much will fit in the circle. Circumference is the length around the outside, okay? Questions on how we did that? All right, same thing on this next problem then. We're going to do area first. Again, the area formula is pi times the radius squared. How much is my radius? It's 15. So pi times 15 squared, it becomes a calculator problem. And what did you get for your area? That's perfect. 86 if we round, yep. And then that would be feet squared. Okay, that's our area. Let's do our circumference formula real fast. That would be 2 times pi times the radius. So 2 times pi times 15. Punch that in your calculator and you'll have the circumference, the length around the circle. I got 94.25 if we round that. And then this would just be feet because it's the length around. Okay, questions on that? Okay, next one then. This one says find the radius this time given the circumference or the area of a circle. So what were we given right here? We were given the area. We know the formula says the area equals pi r squared. So we're going to substitute the 90 in over on the side for the area. And we're going to solve it for the radius. So how do I get the radius by itself? What's the first thing I get rid of? I get rid of the pi. So divide both sides by pi, which is really just calculator work. So do 90 divided by pi on your calculator.
28.64.
Exactly. Yeah, if you round 28.65. And then how do I get the squared off of the radius? How do I undo a square? I square root. So I'm going to square root that number. And my radius is going to be I got 5.35. Is that close to what you got? And it's a length. The radius is the length, and my lengths are in centimeters, so I'm just going to be centimeters. Okay. Next one, I have the circumference, and I need to find the radius again. So the circumference says 2 times pi times the radius. So I have 32 equals 2 times pi times the radius. How do I get the radius by itself? I'm going to move the 2 pi. How do I get rid of times by 2 pi? Oh, I'm gonna divide by 2 pi this time, right? Because it's times by. So it cancels over here to the radius. And on the other side, I'm going to do 32 divided by 2 pi. And when I do that, I got 5.09. And that would be in centimeters because I'm in centimeters. Questions on how I did that? All right, one last problem on the front then. It says find the area if the circumference is 62.8. So in order to find the area, I have to know the radius. I have to know the radius to put it through the area formula. So I'm going to use the circumference formula to find the radius, and then I can use the radius to put back into the area formula. So I know my circumference is 62.8, and that would be equal to 2 pi r. Again, in order to solve for r, I'm going to divide by 2 pi. So I get my radius is equal to I got 9.99. Are you guys all right if we round that to 10? Okay. If my radius is 10, that makes it really easy to put back up into this formula, right? So I'm going to have pi times 10 squared for my area. And when you do that, you get 314.16. And this would be units squared, because it didn't tell me feet or inches or whatever, so we're just going to go square units. Okay, questions on that? All right, we got 2 last problems on the back. Story problems. I'm just going to kind of stay focused on the shape here and read the problem. It says a metal worker cuts out a large semicircle with a diameter of 28 centimeters. Then the metal worker cuts out a smaller semicircle out of the larger one and removes it. The diameter of the semicircle piece that is removed is 14 centimeters. Find the distance around the shape after the smaller semicircle is removed. Round to the nearest tenth. So I really want to know how far it is from here all the way over to here and then back around to right here. Okay. So how am I going to figure that out? I'm going to use my circumference formulas, right? Now, if I found the circumference of this big circle right here, wouldn't I find from here all the way to here if I took the circumference and divided it by 2? Do you guys agree with me that I could do that? So let's find the circumference of the big circle. The circumference of that big circle would be 2 times pi times the radius. The radius of this big circle is going to be 14. So 2 times pi times 14. So when we get that as a decimal point number, it's 87.96. But I only want half of that circumference, right? Because the other half is this part that's not drawn. So I'm going to divide that by 2 to get the half that I'm looking for. So far I would have 43.98 centimeters from this part again up here. Okay, so just that side of the circle. Now, if I wanted to know this part right here, I would do the same thing. I would find the circumference of the whole circle and then just take half of it. Are you following me on how I would get that? So I'm going to go circumference equals 2 pi times r. But this time my radius is going to be 7 because the whole length there is 14 and I only need it to be half of that. So times that out on our calculator and we get 43.98. But I only want half of that, so I'm going to divide by 2 and I get 21.99. So far I found this outside part, and then I found this part right here. Do I know the length of this part right here? It's 14, right? So I'm just going to add those three numbers together. 43.98 plus 21.99 plus 14. That will give me my total of my entire circumference of that shape. So add those together for me. Okay, we're recording, so. When you add those together, what'd you get? I got 79.97. And that would be in centimeters. So do you see how we could use the circumference of the circle formula to find even funny shapes like the piece that was cut out of the metal here? Okay. We're going to do the similar kind of thing down here on this next one. This one says the shape of a tabletop is made from a semicircle, which is this piece right here, and the quadrant of a circle. Do you guys see that this would just be 1/4 of a big circle? So if we find the big circle, we could divide it by 4, right? Because it's a quadrant of a circle. Find the distance around the tabletop. Use 3.14 for pi and round to the nearest tenth. So if I find the circumference of this circle right here, because this circle would be like this, and divided it by 2, I would have this distance from here to here. And then if I found the circumference of this big circle that went around like this and divided it by 4, I would find the distance from here to here. And I could then just add the 60 inches on right here, okay, in order to solve this. So here's a good question. If it's 60 from here to here, is it also 60 from here to here? If this would be a big circle coming around like that, and this is 1/4 of it, wouldn't those both be radius of the circle? Yeah, so this length right here is 30 inches from the center to the edge, because the whole thing would be 60 from here to here. So this piece would just be 30 for my radius of my small circle. So my circumference of the small circle would be 2 times pi times 30. And then I'm going to want to divide that by 2. So I get 188.5 if we round. If we divide that by 2 just to get this piece right here, then I get 94.25 for the distance from here to here. Then I'm going to do the same thing for this part, but I'm going to divide my circumference by 4 because it's only 1/4 of that circle. So circumference equals 2 times pi times r. My radius here this time is 60. So 2 times pi times 60. I get 376.99. I'm going to divide that by 2 to get, actually not by 2, I'm going to divide it by 4 because I want a fourth of that length. So I get 94.25. Again, dividing by 4 because we want 1/4 of the circle. And then just add on this straight length right here of 60. So I'm going to do 94.25 plus 94.25 plus that straight length, which is 60, and that will give me the distance around that weird shape. And that distance is 248.5 inches.